All right. Hello, everyone. Thanks for joining our webinar today. I hope you and your families are doing well. And it's good to see a lot of people from different backgrounds join our webinar. And on this occasion, I'd also like to congratulate all my fellow countrymen on a historic moment that was created today, where India finally won a bronze medal in hockey after 41 years. So I kudos once again to all the players, and now it's becoming clear that India's establishing a mark not just in IT across the globe, but we're seeing our men venturing into sports as well. So that's a good sign, right? So on that note, today we're all set to begin our Q&A session with leaders in automation, industrial automation specifically. And these gentlemen have been a part of the industry and have been solving complex and dynamic industrial automation problems for more than 15 years now, right? So they've seen many technologies evolve, and they've also benchmarked success during this time and in multiple manufacturing verticals as well, right? So I hope you guys take full advantage of this session and implement some of the learnings wherever applicable. On that note, I'll introduce our leader, who is Mr. Raghava, right? And I believe most of you listening in have already, probably spoken to him or are familiar with who he is, right? So he previously was working with Microsoft Technologies in 8. After realizing the manufacturing company's strong inclination for the day, Mr. Jayendran, whom we all, on that note, I'll pass it on to Mr. Raghava to take further proceedings.
Okay, thank you, Adi. I think, it's I didn't know that India won the bronze, by the way. So thanks for sharing that news flash. So, attend webinars and you'll also get, information about what's going on around the world in addition to industrial automation. And I think, on that note, just like India has been leaders in information technology, I think India is soon going to be, leaders in the manufacturing technology. And just like, we beat the Germans in the hockey, we're going to do the same with manufacturing, right? So this is going to be the next Olympics. It's going to be India's game to win. So, on that note, just a little bit of brief series. So we run a series called Machine Visionaries. And it's Machine Visionaries, shortened as Mac Vision, and we interview, guests who have, benchmarked the world in industrial automation related to machine vision and AI, and where there is some sort of intersect with technologies in both industrial automation, machine vision, and AI. And so with me today, I have Jayendran, and this is going to be JB, as he's called. I don't think he would recognize himself if he say Jayendran. And so JB, he and I, we go back quite some ways. So, when I first started Qualitas, I moved back to India from Microsoft, and I was highly told by multiple people, hey, you got to meet this guy JB. So there's like 3 or 4 things. And I go visit him, this is like almost 15 years back in his office in Wilson Garden. And I see this guy. I was expecting, from this really elderly guy, because nobody told me this legend JB, how old he was. So I thought, he's been around for a while. But this young dude in shorts comes in and he's like building some amazing machines. And I was like pretty blown away back then. So since then, he's just exponentially kind of taken NextFirst to where it is today. And we'd love to hear more about that as we get into this webinar. So with that, let me kick it off, JB. And firstly, thank you so much for joining us and spending the time sharing, some of your knowledge and wisdom with us in this audience. So we've got quite a bit of interesting audience as well, and this is going to be distributed later in our MacVision editorial as well as social media. So, let's start with a little bit about an introduction about yourself. JB, what's your background? How did you get into industrial automation, right? Also, it's interesting to know very few people, especially after from an Ivy League school, Stanford, especially coming back to India and then doing what you're doing. So you must be one of the rare breed. So love to hear a little bit about what the thought process was, your background, and how you got started in this field. You're on mute, JB.
Qualitas, Mac Visionaries, and Raghava, first of all, thanks a lot for having me on this panel discussion. I thought this was all about the future, and then Raghava suddenly asked me to talk about history. 20 years ago, all of us were young, Raghava. So now you're asking me to go back 20 years in time and tell you what happened. I not interacted with before. I am basically a grease monkey. I like to design and build automation systems. Myself, throughout my education, to do this, right? I got my undergraduate degree in mechanical engineering. Knew that I'm new today. I think we have a lot of institutes training people in this area called mechatronics, which is kind of the intersection, the overlap between intelligence systems. So that's what I trained to be, and that's what I've been doing. So I'm looking around. What's fortunate is I love what I do. B, I trained to do what I do today, and C, I'm continuing to do what I'm doing. I started my career working with GE. At that time, GE had just set up their Jack Welch Technology Center here in Bangalore. So I was one of the few people who was actually doing hardware work back in those days. That center started off doing a lot of analytical work in engineering. And then, earlier today I was talking about music to somebody, and your question. I started NextFirst. I think the reason was, like we were talking about Pink Floyd's called momentary lapse of itself. Don't have a better justification for doing what I'm doing today. Like someday it felt like the right thing to be doing, to go out and start building machines for a living. So I don't have a great story of I always wanted to buy a robot and nobody built a good robot and hence I built my own robot. That's the story of what I'm doing today. I always want to build machines, and it seemed right to go and start building machines for a living. And that's what we've done, over the last 15 years at NextFirst. We cut our teeth during the earlier days, designing and building automation systems for the Indian market. We did a lot of custom bespoke automation systems, helping people automate assemblies and manufacturing lines. Over the last few years, we have kind of people in the tech world overuse the word pivot. I don't know whether that's really what we did, because to a mechanical engineer, a pivot means you had a fulcrum. We had no fulcrum. Mid-air, we changed course to kind of move from doing bespoke custom automation work for assembly automation to today a lot of our work is around building and solving problems in material handling and material kind. We'll talk about that as we go along. So as a company today, we design and build what we call intelligent material kinetic systems. So systems that help to move material intelligently. The industries that we do that for are primarily the fulfillment industry. So you could be a manufacturing company, you could be an e-commerce company, you could be a retail chain of stores, and you want to automate how to fulfill online orders, and that's kind of what we design and build automation systems for today.
That's a great story. Yeah. So I know. It may be a momentary lapse of reason, but I guess there are a lot of people who are wishing you were here, because I'm sure you solved a lot of tough problems.
The end, I just want to be comfortable young, man. So.
All right. For those of you who don't get it, go look up all the Pink Floyd songs, and you will a light bulb will come in. So that's so. Stanford, masters, mechanical engineering, mechatronics as a passion, came back, started with GE, right? You did a lot of, from starting with material handling automation to now fulfillment, right? So it's come a long way since the time you started as a first. So, and one of the things I've always wondered, right? So automation, what were some of the things, top 2 or 3 things that you can see different. I'm taking you back in the past again, tracking memory. Would you say has been different? Like when you look at the IT side and technology, when I graduated from school and came back, and then really, if I look at things today, the world has completely changed, right? The whole concept of internet, cloud has disrupted a lot of things which we do in daily lives, right? So, and there have been things that have been built on top of each other from this fundamental technology of the internet, right? So earlier it was just a browsing, and it was restricted to a few things in the enterprise world. But what would you say has been that disruption in mechatronics or industrial automation? Has there been disruption, if at all? What are the keys that you see from a couple of decades ago to now?
I think there are 2 dimensions to the question, right? One is what has necessitated a disruption. What have been the trends in manufacturing that have necessitated a disruption from an automation perspective, and what those technology disruptions are. And to appreciate the technology disruptions that have happened, I think it's important to understand what the driving forces were, right? So if we kind of go back to when industrial production became a thing, right? In pre-World War, Henry Ford standing up and saying you can buy any colored car from me as long as it was black, was when organized industrial production came. So over the 100 years, 100 years wrong, maybe from then to maybe the 70s, 80s, right? Technology interventions went through 4 stages, right? The initial intervention was what was called mechanization. How can you get a human operator? I'm sure all of us have seen Charlie Chaplin tightening, nuts and bolts in what was a conveyor line then. And, you had these long wrenches that, they would tighten, right? So mechanization was, how do you put more power in the hands of the human operator? The human operator was continuing to provide force and intent, but mechanization didn't do it. Then was followed digital electronic. That you had these rungs of coils, relays became a thing, and then you started getting some kind of instrumentation in the system. So you had mechanized systems. Electrical power became a thing. Logical gates, transistor, solid state memory, all of them became things in 50s and 60s. So you had the era of instrumentation, where it was still not independently automated system, instrumented system, right? You started augmenting these instrumented system with some logic, right? So that's what we call augmentation. And finally, in the 60s and 70s, when controllers became ubiquitous, silicon manufacturing became easier, you had automation. From then on, I think automation itself has evolved over the last 20, 30 years to, a big change in paradigm in the last 5 years, right? So I would say till about 2010, and there is a very strong role played by the internet, and we'll dwell on that a little more later. Pre-internet becoming available at everybody's fingertips, right? And people may not realize how strong a connection there exists between the evolution of internet, the dissemination of internet, and manufacturing. But till about 2010, 2015, the fundamental promise was of automation, premise of automation, expected promise of automation was speed. If you wanted to make more of something, you automate it. All right. And I have been kind of have been in the thick of things over that transformation of the industry, where 2004, 2005, when I got into this area as an automation professional, you had some kind of a litmus test. If somebody called you and said, I wanted to automate, you ask them, how many of this do you want to produce in a year? If he said, I want to produce anything less than a lakh of something in a year, you say you shouldn't be automating, right? So automation was a word that you used. You evaluated automation when you wanted to make a lot of something, right? And I think what has happened in the last 5 years is mind-blowing, where now you automate when you want to have flexibility. So the promise of automation right now is not making a lot of something, but it's making a few of many things. All right. So in some sense, it's a paradigm change, right? Engineers who had trained themselves, engineers such as myself, who had trained themselves on developing automation systems to say, look, if you don't have a cycle time of 5 seconds, if you're not making 1 million of something in a year, you don't automate, have had to respond to customer asks saying, we make 5 of something at a time, we make 10 of something at a time. But then we do this hundreds of thousands times over in a year, and how do you automate? So I think the necessity for disruption and automation technologies has been this transition from speed, right, being why you automate, to flexibility, agility, being why you automate. And I think that's kind of the transition that, and I've lived this change. I've gone from having worked in an industry like the automotive industry, where you produce the same part over and over again 3 million times a year, to now working in an industry where you ship 30,000 orders a day, where no 2 consecutive orders are the same, right? And so gone are the days when we automated to keep stamping the same part out, to where you got to stamp faster than before, but stamp different things every time over. So that's, I think, where the industry has gone. And I think that is driving a lot of the reason why technologies are needed. This in itself is a disruption, right? I think disruption is a very small word. I mean, this is almost like rewriting Newton's laws, right? It's like, you wake up one morning and say, F is not M into A, F is M by A. And, you have to reinvent everything that you do, right? And this is as big as that. And as, Raghav, you've been in this space for a while. See, the difference, the interesting perspective that we from Qualitas have, we've always been on the silicon end of things. We've always been on the processing, the intelligence bit of stuff, right? And I'm a mechanical engineer. We learned that some time back, right? So I think the intersection between mechanical intelligence, all of that is happening. There is this upheaval going around, where the whole world's trying now to build to the holy grail of batch size of 1. And I think that is what is needing disruption in automation technologies.
Yeah, that's fascinating. The whole paradigm shift of mass producing to flexible automation. So it's interesting how you put it, right? So it's all about flexible automation, doing more of different things than doing more of the same thing. There's a huge difference between the two. It may end up being the same volume, but just think about having, if you're doing 10 SKUs of different things, it's having 10 parallel lines, right? So each one being different. Now, but help us break that down into what are some of the challenges that poses in automation. See, in software, I have a software background. You can go and just copy and paste a piece of code, and then you can make another function, right? Or you put that variable. So it's like, it's a word of difference. But when you said, you translate that same paradigm shift into a mechanical problem, that's humongous, right? So what are some of the challenges that you face when making that shift into, let's say, a line or a company that's doing one part 1 million times versus having to do 20 different things or variations?
Yeah. So I think it's a very interesting question that you asked, Raghav. So let's address it from an engineering level, right? Any system that has to be agile, any system that has to be flexible, intrinsically has to be stochastic in it, right? You have to be able to deal with randomness, because the very, very nature of, by needing to be flexible, by needing to be agile, what you're saying is, I'm going to give you unknown stimuli, and I'm going to expect known responses back from you. You don't know what you're going to be asked to do. The cycle time, think of the track time, but you have to be able to. So the system has to become random in nature. Mechanical systems are not random. You come from a software background. It's random access memory, right? Is kind of where everything that you build runs, right? The vision processing software that you build, the filters that you run are all running in random access memory, right? Which is why it is very easy to imagine how the software portion of automation can deal with this randomness. The moment it is random, then agility is part of randomness, right? I mean, you're an agile system. A serial production is nothing but a unique instance of a random system, right? Where every consecutive thing is the same thing. In mechanical systems, that. So some of the challenges of the wheel is trying to which were sequence systems to solid state memory, which is right now. In mechanical industry, what has happened is, fortunately, we have broken it down smaller problems to solve. All of us being engineers, right? The process bit is getting robotic. People hear the word robotic process automation, when you think software, but if you look at the English of it, right, it's the same, right? So if you walk down a shop floor, you see a whole bunch of manufacturing processes. You just remove all of them and put robots in, right? Fundamentally, you've created something that is random in nature now. You can reprogram them on the fly, right? So a big trend that you will see is the number of robots. So if you go online and track how many robots are being sold, you will see that it's not a linear function over the last 5 years. It's a hockey stick over the last 5 years. Because the only way you can now produce, right, things, every subsequent one being different, is by putting a robot, right? So that problem has a lead on being solved. The problem that is not solved is the problem that we at NextFirst are attempting to solve, which is now I set up a series of process stations, right? Each of those process stations in the real time can get reconfigured to do anything, right? But you still have conveying systems, you still have material movement systems that move from one station to the other sequentially. So we think that there is a ripe situation to disrupt movement of material, create a random access movement platform, which is a platform that we at NextFirst have built called Cart Plus. For those of you who are interested, you can go online and check us out. We'd be happy to talk to you guys about how we could solve material handling problems in your context. But fundamentally, the intelligence portion, like you rightly said, is easy to be flexible. From a hardware and a mechanical side of things, right? Robotic process automation sitting on top of intelligent material handling is kind of where we expect the industry to be going around.
No, that's interesting as you mentioned, right? So it's the amalgamation of software and mechanical, and here you have a robot which can dynamically move based on what the software commands it to do, and so seeing more of such units of automation being adopted in manufacturing line is how the change is coming about, as opposed to the line being very rigid in terms of what it could do. And so it's this dynamic nature. That's really, that leads me kind of to the next area, right? So when you talked about Cart Plus and your entry and focus area into logistics and e-commerce, which has seen a huge boom, especially in the last 18 months. Now, how do you keep abreast? I have this challenge, at least in Qualitas, and we're working with AI and deep learning. You wake up and the state of the art has changed. You sleep and you have something that's completely disrupted, the intelligence. Now, how is it for you in automation? And I'm sure you're seeing the same thing over here as well with the shift that's happening. How are you keeping abreast of technology, latest innovations, and how do you sort of evaluate, what do you build, innovate versus what do you reuse versus, how do you define strategy as CEO of NextFirst, as a chief product officer? Is that your official title? Maybe a chief design officer?
I play 3 roles today.
Yeah.
I'm designated the CEO, so which is what I do as part of the senior leadership team here. But functionally, I do both the PO's role and also some amount of product management. Of course, as a growing company, we are trying to find the right people to kind of come and lead these functions. I'm not going to tell you ask a good question. It's a very tough question you asked, right? And I think no matter what question you're going to throw at me today, this is one of the toughest questions to answer. Because I think, there are various dimensions to answering your question, right? Personally, as a professional in the area of automation, you have to answer this question to yourself, right? The second and more important question is, how do you answer this as the CEO of a company, right? Because this now means you need to have a culture of learning. Our people are constantly learning. You need to have a go-to-market strategy that can keep up with not only changing technology, but changing customer expectations based on their understanding of changing technology. I remember, back in 2005, 2006, we were building something for a customer, and he wanted us to do something that was the equivalent of change the flow of a process in an automation system that we built. Pretty much take process and right? It's almost like you have to turn the newspaper to find out what is SOTA today, right? And then you're dealing with customers whose expectation is driven by their understanding of SOTA, right? I think that is a harder problem for us to solve. We are nowhere the best guys in doing this, but I can just share my experience of what we do at our company, right? Some of the things that we've done in the recent past are we have gone through. We have a very high contribution of youngsters in our team. We've realized that if we are going to learn technologies that are very different, right, we might as well learn it for people for whom it's not very different. So we found that the youngsters adopt technologies much faster. They're able to learn much faster than us. So one thing that we have done is we have increased the component, the percentage of people in our team who are youngsters, right? A couple of years after college. That's one thing that we have done as an organization. We learn a lot from our partners, right? We try and not do this, get 3 quotations for anything in our company, because we realize that knowledge as a vendor, they're actually bringing this company called Qualitas for all our, we collaborate with Faruk for all our robotics needs. This is their job, hence they are more than us to stay on top of the SOTA curve on their businesses, and we, by ensuring that we do all our motion work. Are they the best? I mean, they have not come out of a detailed thing that we do is when we go to our customers, if somebody tells us that your competitor is doing this better than you, the salesman in me in that meeting tries to convince the customer as to why we are better than them when we come out, but then we take that feedback very seriously. We go back and see what they are doing. Are they doing something technically different from us? Is there something we can learn from the way they are solving the problem? So these are things that we try and do as an organization.
Yeah, it's very interesting. So you mentioned, you hire freshers, right? And so you keep things open because they don't come with some preconceived, because things are changing so fast that, what they've probably learned in the 10, 12 years back then is no longer applicable now. So you just have to start from a clean slate.
I am amazed with what I learned from the youngsters in my team on a daily basis. I mean, it's amazing. I'm not saying that, people with experience are, obviously people with experience are super important because they're the adults in the room. They do adult supervision. They bring wisdom. They ensure people don't make mistakes. They ensure when people do hard, right? But I think the fact that we are expecting to learn things that we ourselves don't know, let's along with people who can learn things as fast or faster than us, is the broad thesis.
Yeah, that's super interesting. I think that you hit the nail on the head. So that, in fact, we have a lot of students in this audience as well. It's going to get distributed. So this is something to take, because I think I say this as well, because when I talk about deep learning in the state of the art, I have this analogy where, problems which PhD is in Stanford, and I definitely see smart people coming out of Stanford couldn't solve can be solved by high school, couldn't solve 5 years ago. Those kind of problems are being solved by today. About there, keeping your eyes open and then learning and reusing, right? And so there's no better way. My 6-year-old is, figuring out things on my phone that I didn't know exist. So it's just that curiosity in you, which I think is innate with the youngsters. So I think I've seen that as well. And it takes a lot of courage though to recognize that and put that into action, right? So as a CEO of a company, that's something which takes some courage and it does pan out.
And it's interesting that you mentioned that I'm just dealing with a little bit of bad internet. Give me like 2 minutes, I'll turn my video off. It's interesting that you mentioned that because the moment of epiphany was when I saw my parents reach to my kids to solve issues on their phones, right? And as far as if you were to abstract the situation a little bit, the phone was new technology for them, right? The state of the art for my parents. And in downloading and installing WhatsApp, let's call it that, right, was what their peers had asked them to do. And what did they do? They went to the youngest generation that they could have access to get it done, right? And that's really when it was a moment of epiphany for me.
Yeah, very true. Technologies that you've been exploring and getting into is this intersection of software and AI. It's all coming with machines, right? That wasn't the case 10 years back. It seemed like this rocket science discovered
right? They have at play for hundreds of years. In formal structures, they've easily been at play for 50-60 years. I think for AI to become a thing, you needed a few. It's one of those melting pot situations, right? You needed the right condition for coal to become diamond, right? You needed compute power that's cheap. You needed easy access to training data. It was not proprietary. And you needed people who were willing to pay for it, right? I remember when I was in engineering college 25 years ago, a lot of my colleagues in the computer science and related departments, their final year projects was neural networks and genetic algorithms and whatever, right? So the mathematical construct that they've been around for forever. But back in those days, when they wrote some neural network code, I remember they used to have to go and book in a computing infrastructure at Tata Institute of Fundamental Research in Bombay, and that will come 3 months into the future. And on one Saturday morning, they will go with their code. I don't come from magnetic tape and punch card. And then they would spend a week in TIFR running their code, right? Not cheap. That was needed to train their learning was proprietary, was available only inside some select. I think where we are in history, it's logical that you start looking at artificially intelligent inferences, right? Because all of us have computation infrastructure that becomes so cheap now. I'm sure that my cell phone is more powerful than the best computer that we could lay our hands on 25 years ago. I think trends, and you spoke about the internet sometime, these trends in internet have ensured that data has been democratized. Most data democratic right now. So you can do stuff, right? I think my first brush with vision earlier was when I started my career, right? I mean, my very first project that I did as a professional, fresh out of grad school, back in 2002, involved cameras, involved C code that we wrote to process some images and actually like move a gantry robot in real time, guided by stereoscopic vision from through camera. It was a project that took a year to do. I had 7 people doing this. Available then, you didn't have. So I would say, so machine vision I've been experienced, so that's good. I can see how things have changed. I think a project in it. You put a camera, you wanted to put it, and you wanted to put edge findings on square boxes that came on at the very. If we kind of break that down to the simplest problem, right? That was a project. 3 months. You made mistakes on camera selection 4 times over. You had big PC that you needed to do this. Then that went to, we saw vision sensors emerge, where you need not do a lot of this. Box, this is no box. If something like this shows up, it's a box, right? Then we saw smart cameras emerge, 2010, 2015, where that computation became so cheap and compact. So the computer was the back of the camera itself, right? And then you would have some training functions. You would have some front ends where you could go draw boundaries and say, if you see something like this is the object. So 2010, 2015, I think we saw a lot of smart cameras. And I would say with AI-based machine vision, industrial grade, ready to deploy, I would say we've been only doing for the last maybe 2-3 years. Even as late as 2017, 2018, a lot of industrial machine vision stuff that we did were heuristic, if then else in nature. A lot of the custom aspect of it had gone out. We could buy off-the-shelf cameras and do it. They came with easy to implement user interfaces that you could go and teach stuff on what is good, what is bad. But it's all if this then that, if this then that. But I would say definitely in the last 2-3 years, we've seen a huge jump in what we're able to do from a machine vision perspective. And that's not purely driven by technology. I also think that, we are all industrial people, right? My customers have been seeing on their own smartphones a lot of vision-based, image-based stuff, right? When they've been downloading software that allows them to categorize beach vacations from hill vacations, family photos from dog photos, right? So I think there has been proliferation of vision and image-based stuff in consumer tech that has made it easier for businesses to accept. See, in general, most of businesses accept has been validated first in computer, then it comes to this, consumer, and then comes to this. So the fact that as consumers, business buyers have become a little more familiar and okay with image-based stuff has made it easier for them to take decisions as business in their business avatars. So I would say it's a combination of technology, people becoming familiar with it, and problem statements that are now getting so nuanced that it's impossible to capture with traditional heuristics-based vision systems. I think these are the 3 things that have made the acceptance of machine vision, AI-based machine vision, a lot more in the last few years.
Super interesting, very insightful, JP. So yeah, I agree with you. There's a lot of drivers, access to large data, willingness to pay. That's important. That's always the motivational factor for any kind of adoption of technology has to be a business objective. And the computational algorithms that have now made exponential strides. Moore's law is on steroids when it comes to AI, right? The kind of things that NVIDIA is just blowing away what Moore's law had predicted about GPU based compute. And so when you see these innovations and you're seeing also the acceptance, no longer it used to be a scary thing when you go and took a camera or some AI and algorithm. It was more like, will it actually work? Is this going to screw up something on my machine? Because I got to be 100% reliable. My OEE needs to be 99 point whatever effects. I don't have the bandwidth to really mess around and experiment, right? So, but as you said, now people are getting the acceptance, having seen this in the consumer space, they know it works, right? So if it can recognize a cat versus a dog, I'm sure it can
a good part from a bad part, yeah.
Variant A with variant B. A good part from bad part, right? So there's a little bit more acceptance in terms of adoption, what would you say is the general resistance or the top challenges faced in adoption of these technologies amongst either by machine builders and technology providers like yourself, and also from the eyes of an end user, right? So when it comes to innovation and adoption of innovation, what do you think are the top challenges that you come across, and what would you say are, is maybe some insights or advice you could share to anyone who's listening, who's evaluating new technology for adoption as an end user?
I would break objections, challenges across sectors, all right? One is, if you look at the end user, right? Somebody at the end user level who's actually going to deploy this on the shop floor. I think one of the vectors is technology awareness, right? I think the moment you put AI out there, it's like the equivalent of what software was 20 years ago. Software could do everything, right? So the expectation that AI can do everything is kind of, and this happens with any new technology, right? I think it's the fact that they don't yet get the technology because they've not seen it used, and their expectation that it's new technology, hence it can do everything, right? Is one of the challenges. So building technology awareness, building education around what is possible, what is not possible. I think that's one of the vectors, from the challenge perspective. The second is, I think, and this is something that we struggle to get our customers to understand. And this is not just about AI, right? It's not just about machine vision and quality. Just like we spoke about how technology is evolving and we have to keep up with it, businesses have evolved, right? I mean, 5 years ago, you walk through a manufacturing facility or a manufacturing industrial area anywhere in the world, and everybody would have boards on 0 ppm, 1 ppm, 5, 10, strive for 10 ppm as their quality indices, right? I mean, today, what is quality by organizations is not number of parts per million on a production line. It's the number of tweets by angry customers. It's actual measure of quality, right? And how does that flow down to the shop floor? Hey, are you able to hear me? Yeah. So, how does that flow down to the shop floor, and what does it mean in terms of technology interventions in the shop floor? Are very different, right? When you were doing 0 parts per million, you could use conventional paradigms of fishbone diagram. We'll find out where are the things that will go wrong, FMEA. We will find out what are detections. Can we put a light guard and do a detection? Can we put a photo and do it? We can do that, a very theoretical academic exercise. How are you now going to deploy technology to ensure that Jeff at Amazon.com does not get more than 20 emails in a day, right? 9 billion orders they fulfill in a year in the US, right? I mean, all it's going to take for the quality of that thing to collapse is one email to Jeff at Amazon.com, right? Now, what kind of technology interventions are you going to put there, right? So, working shoulder to shoulder with customers, understanding what is it, and this is, like I said, this is not just with machine vision, right? This is about working shoulder to shoulder with customers and understanding what technology interventions, where is their business going, what are the performance metrics for their business, and how do you put technologies on operating floors to achieve that. I think is the second challenge, because businesses themselves are rapidly evolving, right? It's older constructs of business just don't hold together at all. And assuming that you've gotten the end user aware of technology, assuming that you have gotten them to understand that this is what they have to do in the complex context of their business, the last challenge is educating them how are they going to start their money from the second day after they deploy the system. right? What is the ROI? And the ROI frameworks again are technologies that are changing. I mean, you and I do business together, right? I mean, our companies do business together. And if you look at how your costs are and how your costs to us are and how our costs are, they're not straightforward. You buy X, you sell it at Y, I buy Y, I sell it at Z anymore, right? I mean, there is a recurring expenditure cost of your inputs. There is a recurring expenditure cost of my outputs. The customer is going to take up some operational cost, right? So ROIs themselves are becoming very complicated, right? Simple Excel sheet saying you spend 10 rupees, you save 5 rupees a year, hence your ROI, cost of capital worked in, is 27 months. It's not happening anymore. So the third challenge is, how do you help people demystify ROI calculations? I think these are the three big challenges of helping people accept technology.
Oh, super insightful. Yeah. So you're saying, educate customers on the technology, set expectation, what's possible, what's not, then align business objectives to technology. So, quality not being, defects you find in the manufacturing floor, but, the impact of quality that you see amongst your customers and how that aligns with your adoption of technology. And that's success, right? So the measure of success basically has to be better defined, and both from a functional perspective, KPI, and then from a business ROI perspective, how does it translate dollars? And yeah, that's, I think we're seeing that challenge as well, because then, once you do that, then technology just becomes an enabler, because now you're selling outcomes, you're not really selling technology. So adoption becomes adoption of an outcome, and it's not whether you use AI or BI or whatever, it doesn't matter, right?
I will give you an example, right? I mean, in our pre-avatar, when we did manufacturing lines for the assembly companies, right? You hit 85% OE, you went, celebrated, you broke open a bottle of champagne, you went back home, and you were constantly refreshing your bank account to see if the paycheck hit you, right? But in the e-commerce fulfillment industry that we work in today, 90 OE is an irrelevant metric, right? Because even a 99.9% OE, right, unheard of in manufacturing. If you're doing 10,000 fulfillment orders per day from that particular location, you're going to have one angry customer every day, right? With a 99.9% uptime, right? So this is not about how can you now make something. This is a paradigm change, right? So, and this is where I think customers have to evolve. We as technology providers have to evolve. So OE definition cannot be anymore, uptime by available time, right? It's not OE anymore. So this is kind of, I'm just motivating the fact that business metrics are changing, businesses are changing, we have to change. And that's one of the challenges.
Yeah, very true. And so, by the way, I also, for the audience that are out there, I see a couple of questions. And so if you have any questions, we're going to be, taking a few more questions, which I have from my script. And then I want to, take some audience questions as well. And, Ravi, ask the good questions about automation. And so if there are others, please type it in the chat window, and we're going to come to that, after the next couple of 10 minutes or so. So please do type in any questions that you would like to ask, and we'll collect it and make sure that we stay long enough to answer all of your questions. So JB, yeah, so one of the interesting things, so I just like you learn from your vendors. I learn a lot from partners, and I've learned a ton of things from you. One of the things is your approach to business and how you've been looking at what you call the Quit India movement and going outwards to international audience. And so I'd love to hear your thoughts. You share a little bit about what you see as the primary difference. You've done a lot of work in India. You have exposure about education both in India and the US. You've done work in India and the US. You've done business in India and the US. So compare and contrast a little bit about what you see as both cultural and technological differences between the two within our motherland and outside.
I'm thinking to ensure I'm able to give a as complete a response to your question. I don't think there's an answer to your question, right? I mean, culturally we are very different. I mean, it's going to be culturally, it's going to be very hard to find another culture like India. Like, not find a culture like any other. The cultures are unique. But I think it still behooves an attempt at making a comparison. See, I think, and I'll try and restrict it to business interaction, that area, right?
That's what I.
So what we have. So there are.
I was, more specifically with technology adoption, right? So when the point that we talked about in the last thing. So, how do they? Is it the same problems that we see, the challenges that we see, in India as well as is the West more amenable to adoption of technology? Are they more risk averse versus in India? So in that context.
So good, and thanks for qualifying that, because I felt like you gave me a question that needed me to write out an encyclopedia. I think around the dimensions that you referred to, most Indian business context, right? I would not say all. Most is playing catch up, right? I mean, there is a Western construct. I mean, you're either trying to be like a company that in the West, or you have a customer in the West who's forcing you to do something in the way you're doing it here. So most Indian business context is around following, is not around leading, all right? This imposes a lot of challenges on technology adoption, because what you perceive to be state of the art is possibly not what customer overseas perceives to be state of the art, or what your customer or what company that you are modeling yourself on has perceived to be state of the art. So that's, I think, one big challenge that we see. When we work with customers in the US, technology being a key differentiator for them, no matter whether it is in their product or whether it is in their process. It could be what about their product is a technology-based differentiator, or what about the way they build their products being a technology-based differentiator is a very, very specific aspect of how they assess their own businesses. So they are a lot more open to evaluating what technology you're bringing, and we come from the process side of it, right? I mean, we don't help our customers build products. So how unique is the technology that we are bringing, and what business differentiation is that going to create is I think a very important aspect of how they go about doing it. Whereas in India, it's a lot more on conformance. Will my customer accept what technology I'm putting on my shop? Things are changing, obviously. I mean, it's that's why I say, if you'd asked me this question 5 years ago, I'd say all of India. Now I think, with the emergence of a lot of India-based business models, I think that is changing. So this is one change I see, how they perceive technology to be a part of their differentiation. The second thing that I have seen is traditional Indian manufacturing was debt funded. All right. Today you can sell to a lot of your customers, my customers may be SoftBank funded, but most of Indian manufacturing was debt funded, which means if a CFO drew up an Excel sheet and says, I'm going to spend 10 million rupees on this particular investment, the project is going to get done in 120 days. He has already committed to a bank that the first EMI is going to be paid with interest on the 121st day. So you could not fail, all right? If you failed either on your performance or you failed on your deadline, then the business is going under, right? So it made people a lot more risk averse, right? A lot of US businesses, traditionally, I mean, I'm not even just talking about Silicon Valley and Sequoia-led businesses. Most businesses in the US capitalized themselves very well before they actually made investments. So a lot of growth investment in the US was equity fund. So it was a lot more risk. They were open to risk. So you do not have the challenge. So legal obligations are different, right? I'm buyer, you're seller, you're buyer, I'm seller. I am promising something, you're delivering something. That's a different aspect. A business that is a project champion, right, is open to failing a little bit, right? Because they don't have the sword on their neck that, if this does not deliver 100,000 parts a year, I'm not going to be able to pay back my EMI. So that is what drives people in the US to be a little more West, to be a little more, I say US because that's my primary market, to be a little more open to taking technology risks. A lot of our work, unfortunately, is around automating manual tasks. And it's a very good question, I think, Ravi asked, and let's talk about that in some time. So we find that since we automate tasks that would otherwise be done by human operators, their ability to spend on automation and technology is a little higher out in the Western India. So these are, I think, the three top comparisons.
Yeah, very interesting. So that's an interesting correlation. So risk averse and risk openness to risk versus how the business funding for any kind of venture works, and also the followers versus the innovators, and lastly you're talking about the pay disparity which drives automation when it comes to the drivers of automation, the cost of labor. So I think I want to we are nearing the hour that we budgeted for this webinar. So we see a couple of audience questions. So JB, you want to take a stab at what Ravi is asking? With automation happening, what's the impact of jobs? What are you seeing? Are you, what's the kind of response you're seeing from your customers? Because you build total material handling automation. We do a small part. You completely disrupt assembly lines, right? Both greenfield, brownfield. So what happens to the people?
So if the question is, are there going to be job losses? The big and resounding answer to the question is no. The only thing that will result in job losses is if consumption goes down. If people in general buy lesser one day to the next, then there will be job losses. I think what will happen with automation, what is not will happen, I'm seeing it happen around, not just around here too, is for line workers, there will be a big enhancement in dignity of their labor. They will be able to work in more humane conditions. They will be able to work more earthly hours, and they will not have to fatigue as much as they fatigued before. That is what will happen to line workers. There will be a creation of a new slew of jobs. With equipment is going to come maintenance. With equipment is going to come upgradation. With equipment is going to come, scaling up. Right. So there's going to be a new slew of jobs that will get created, which will get filled by line operators who upskill themselves. So I was operating a press. I learned how to do CNC programming. So now I program presses. And hence, I'm still part of the automated future, but I'm not doing a completely different set of tasks. The second thing that will happen. And the third thing that I see from a job creation perspective is a secondary and a very important is this new set of people will have to be trained. So I think there will be an ancillary set of jobs that get created in training. So if anything, jobs will only be created by automation.
Yeah, completely agree. And we're seeing that as well. The more automation comes about, the more demand there is for workers in the US. And look at the US, it's scarcity of labor. We're talking about an advanced manufacturing nation. The other question from Priyanka, I think she's asking, how do you sell? If I were to summarize, paraphrase, how do you sell to customers? Things are very labor intensive, and the cost of labor is very low, and in the result, the appetite for investment is also low. So what would be a strategy here in the Indian market that you've seen for industrial automation?
So, see, I think And I think, Priyanka, you've asked a good question. If you are somebody who's looking at doing technology selling, right? I think the fundamentals of technology selling are agnostic to where you're selling, right? Don't sell based on cost. Sell based on value. But understand what is the fundamental value you're creating for your customer. Run your customer's business for a day. Understand the P&L of your customer. Understand how your customer makes money, how your customer generates revenue, how your customer makes money from that revenue, right? Understand where your product fits. I mean, is it increasing revenue? Is it in cost? You have to achieve one of these two things if you're going to see, right? If it is not increasing revenue, if it is not reducing cost, and somebody is still buying it, they're buying it for vanity, all right? I mean, I want to buy a car. There is a car that can take me from place A to place B that costs me 10 lakh rupees. It does everything that I want. That's a value. But I spent 1 crore buying a car, that is vanity, right? So if you're not able to justify in your own mind, as somebody who's running your customer business for a day, where your product is generating either top line benefit or bottom line benefit, your customer will not buy your car, all right? This has nothing to do with India. It is the way you sell technology. Challenges that get imposed in India are the following, right? There is tremendous demand volatility, right? Traditionally, Indian manufacturing, your customer would come and say, set up a line. I would buy 100,000 parts from you every year. Because I won't even buy 10,000 parts for you, right? So the pressure that an Indian entrepreneur, the pressure that an Indian business owner, P&L manager has, is they have to invest to amortize it over. So realistically will end up happening. So they would want to 50,000 parts, they will divide it to 50,000, and you know what happens to your ROI, right? Recognize it. If you see that this is a challenge, go and ask the customer, look, you want to set up 1 million parts. You know that your customer is not going to pick up more than 50,000 parts, but you have to show that you have 1 million parts capacity. Do you have 20 products that I can run in the same line? Which means now I will set up capacity for 1 million. If one customer gives you order for 1 million, run it. If he doesn't, run 20 products, right? So this is where understanding your customer's mind, this is where understanding what are the vagaries of your customer's business and how can technology help solve that will let you propose your value correctly to the customer. And the last thing is, if your customer is not making money, is not saving money using the product that you're not going to buy, right? So, and the pressure of putting it in a way that they understand that is yours, Priyanka, it's not the customer. Please understand that you have one customer to sell to, the guy has 10 guys he can buy it from, or 10 guys he thinks he can buy it from. Pressure of putting it in a way that they understand as technology salespeople.
Yeah, I would echo that wholeheartedly. I think, we learned the hard way where, your value-based selling versus cost-plus based selling. And, if you go cost-plus, you're just rolling the dice. But if you go with value, there's no way that, you make a sale unless, he doesn't trust your question from Parth the high. And so Parth is asking, okay, so we're talking about AI, and AI is generally in the context of software, and because it's all code, you can, things change dynamically. But if you put this in the context of a mechanical system where things are more physical, then how does AI come into the picture in that context? And
I briefly spoke about this part, and this is a fascinating subject, and I've been working on this space now for 2 years, and I see myself doing this for a good amount of the near foreseeable future. If a mechanical system has to be able to respond to learning, all right? Let's understand what is AI, right? AI means that you have a system, the system responded to a stimulus today in one way, and then you keep giving it various stimuli, and a few days from now it responds to the same stimulus in a different way. this difference in its response is what is called learning, right? Now, for this to happen, the mechanical system has to be able to do various different motions, because the response of it system in a mechanical context, how it moves, right? So, good example is a robot, right? A robot can now move in various different ways. So that gives you, as somebody who's programming these mechanical systems, with tremendous amount of power, right? You can now say, I'm getting this input. Today, I'm going to make the robot move in a certain way when that input comes. And I keep giving it inputs. I keep finding if this motion is the best motion. Over a period of time, you learn this is not the best motion. Another motion is the best motion. And it starts responding differently to the same input, right? So you are able to now get this mechanical system called a robot loosely to learn, because it can move in a very random fashion. So I think the fundamental, the building block of mechanical systems that can respond to, that can learn, right, are systems that can move in infinite ways. If I give you a motor, right, let's start off with one motor. If that motor has one variable, right, it can move maybe two variables. It can how fast it spins, how much it spins. Now, if I put two motors next to each other, now I give you four different variables. If I put 6 motors next to each other, now you get infinite variables, right? So I think the building block of mechanical systems that can learn are systems that have to be random, right? So if you don't have a system that you've architected, but then you and I can talk about it offline if you want, because it's a very fascinating subject, right? So I spend a lot of my time architecting our product platform called Plus, which is that's what it fundamentally does. It's a system that can move in one of infinite ways. And because it can move in one of infinite ways, it can now come up with different responses to the same inputs. So at the base of the system, a mechanical system that responds to should be a system that can move randomly. If it does, then the rest of it is software magic. A crude example is, no matter what you do to me, I cannot run as fast as Usain Bolt, right? I mean, the fundamentals of the mechanics have to change for it to be able to respond to inputs. So, this is just the beginning. It's a very vast subject. I'll be more than happy to talk to you offline part if it's of interest to you.
Yeah. Thanks, Parth, for the questions, Priyanka and Ramesh as well, and Ravi. So it looks like we're kind of ending the webinar. We're pretty much done with the scripted portion. Any other questions, we're happy to take it. But I wanted to spend the last few minutes before we wrap up and learn a little bit about what's keeping you busy, JB. What are some of the current things that are at the top of your mind within NextFirst and with your focus area? What exciting things are you working on, and what should we look out from NextFirst shortly?
So one of the areas that I'm personally working on in my role as the CTO of the company is exactly the question Parth asked. So we have architected a mechanical system now that can learn, all right, that can respond to learning. So a lot of my work right now in the company is how do you now infuse learning into a mechanical system whose basis is random motion. So in the near future, you will now start seeing a lot of intelligent versions of our smart conveying and smart material kinetics. Yeah. What's keeping me up at night? I think, and this has nothing to do with technology, I think business continuity in the context of how the world will look tomorrow based on Corona, right, is something that is keeping me up at night. I'm sure that 5 years from now, if anybody in this group believes that the world is going to be back to what it was before Corona, we're just delusional. Everything about the world is going to be different, right from how our children are going to learn, to how our customers are going to make business decisions, to how we are going to service our customers' requirements. I mean, today, if as a customer, I'm getting my son to get training in math from a teacher in Jodhpur on something that I would just not have even imagined in my wildest of dreams 12 months ago. Nothing prevents my customer to do the same thing, right? I mean, they can now go to vendors that they never imagined that they will go to. So everything about the future is going to be very different from what it was before. It means different things to various aspects of each of our lives. It means different things to us as individuals, as parents, as professionals, as as managers, as business owners. So that's definitely something that keeps me up at night, Raghava. And more importantly, how can we find solutions to these uncertainty using technology, right? I think technologies around intelligent systems, AI, can definitely be used to deal with this. They are fundamentally systems that learn. So if they're systems that learn, what was uncertain to them today is certain to them tomorrow. So that's what keeps me up at night.
Yeah, interesting. Yeah. So, how do we look into the crystal ball?
Yeah. I mean, I'm looking at the crystal ball and I'm only seeing
adapt to what's
right now, right? No, I don't know what that means.
Yeah, I see just clouds. So, it's so cloudy, right? At least you're seeing fireworks. You got a little bit more clarity than I do.
Yeah.
And so, final question for the evening. Thanks for staying up. I think we had quite a few had to drop off, but I do want to get this last question in terms of what is last when it comes to actual business, where it's not so much into the crystal ball, but what you're seeing as just coming out of COVID and the lockdown, and what are you seeing in terms of how it was 2 years back versus today when you talk to customers? Are they a lot more open? I see a lot more demand for your products. So
yeah.
What's like this one thing that has obviously changed for you?
Yeah. So I think in the market that we are in, which is primarily North America, in the industry that we are in, and I think this will apply to any market, any industry. I think the one is very clear is if I am perceiving my future to be uncertain, I am not unique. Everybody knows that their future is uncertain. People looking at me building into their businesses is very, very apparent now. How can I leverage technology? How can I deploy technology to be more resilient? I don't know what is going to happen 2 years from now. There could be COVID-21, there could be less people, but the one thing that is clear is demand for anything that I produce is going to go up. So how do I now deliver to my growth? How do I deliver to my business? By making myself resilient. And I think everybody is looking for technology answers to that resilience. So what we are seeing definitely in the last 2 years, and to me, I think this is a great time in the history of mankind to be an automation professional. Because part of this resilience is going to be how do you now provide automation solutions. It could be automating vision-based stuff, it could be automating material handling stuff, it could be automating robotic process automation. But the word automation is a very important aspect of business resilience built through technology. So from a macro trend perspective, we are seeing our customers to be a lot more open to evaluating technology, but a keen lens that they're evaluating technology is it making my future more resilient to uncertainties?
Yeah, that's very positive for people who are listening in, because most of them are from the industrial automation or have some kind of inclination towards industrial automation. So I think, with that, I'd like to wrap it up and thank you, JB, for all your insights, your time. I had a fun conversation, a lot of it which I hadn't had a chance to talk. I know you and I shared a lot over informally, and we talk a lot about what's in the crystal ball, and I enjoyed our conversation as always. So thanks again. For others, the attendees, thanks for staying up. Quite a few of you who signed up, and I know a lot of you couldn't make it. For those of you signed up, so for those, you will be seeing a recording coming out shortly. You'll get it in your mail if you registered. Otherwise, or go to macvision.it, which is our machine vision editorial. is interviews similar to the ones we had with other automation leaders, and they're going to be a series of these that we're going to be doing. So there's a lot of learning and exciting content that's coming your way. Subscribe if you can, and hope to see
Hey,
you
Raghav,
in one of the upcoming series.
Quick 30 seconds. Thanks a lot for having me over. I think the questions you asked are topics that are very relevant to everybody, no matter what you're building, no matter what you're buying, no matter what you're selling. I, as always, enjoy having conversations with you. So really appreciate you having me over. Thanks to the patient audience who are here and anybody who's going to listen into our conversation.
Yeah, thanks, JP.
Thanks a lot.
Thank you.
Take care, guys.
So have a great night. Bye.
Yep.